please, everybody, a warm welcome. We're going to have a session, common poor coding practices and how to avoid them. So from Patreon, please welcome Alice Yuan.
Hey everyone, I'm Alice. I'm a senior engineer at Patreon, which is in San Francisco, but I'm actually living in disguise as a Canadian there. So I'm pretty excited about this talk because I'm giving my first talk in Canada, and this is awesome. So I want to talk about poor programming patterns, and the reason why I want to talk about it is when I first started in the tech industry as an engineer, I had a lot of misconceptions about being an engineer. I thought that being a good engineer meant writing a lot of code. And not only writing a lot of code, writing it really fast and shipping it really fast. And so I wrote a lot of code, and then I was like, the code base grew, and I looked at the code again, and I was like, this doesn't make any sense. Who wrote this? And of course, it was me. Whoops. Well, I've come to realize that although we have the best intentions, we aren't able to predict every single problem that might occur in the code base. But we do end up making a lot of the same mistakes over and over again. And so today, I'm going to be talking about 4 programming paradigms that I see a lot in the code base that tends to make a lot of complications down the road. In order to do this, I have a light demo app. It's using the Pinterest API. And all it does is you're able to log in, and then you can see your profile page. And then after, you can also search for other people's profile pages and follow them. Really simple, right? It only took me like a few hundred lines of code to write. And you can actually read this code on my GitHub and diff the solutions to the different problems that I introduced in this code. Yeah, so let's get started. Problem number 1. So our first problem is with the UI. And it's that we have a really simple UI, but for some reason, it's a pain to add new features. Why is that? Well, let's take a look at the design. For example, in my current design, I have this text that says how many pinners I'm following, 25 pinners. And I want the new design to say that you are following 25 pinners. Or if it's the pinner fragment, I want to say that Ben is following X number of pinners. Just a simple text change. But for some reason, this is a lot more difficult than I thought it would be to do this. In order to investigate the problem, let's look at the architecture. So we can see that my profile fragment and my pinner fragment has some shared view and probably logic. And so being the smart person I am, I decided to abstract all of that logic out into a base class. And so that base class has all of the shared logic. So here is the base class. And maybe you might already see some code smells in this class. One of those code smells is that we have protected member variables, which means that I can change those variables from any of the classes that I inherit this, and it can make it a pain in order to debug what is actually editing that variable. And another code smell is that we have logic in the base class that can change. So this means that if I want to update the text of one of those variables, then I have to make that change in the base class and any other classes that inherit that base class. Lastly, this is the classes which inherit the base profile fragment. And we can see that we're overriding and re-implementing the logic over and over again. So even though we have some base logic, we still have to do additional updates to that logic in order to make it custom to our current view. Well, this seems easy enough. But there could be cases where we actually have more than 2 variations of a same class. Let's, for example, assume that we have experiments going on these classes as well. So now we have a ton of different fragments. And in order to change anything that exists in the base class, we have to edit all of those fragments. And this is what we call inheritance hell. So how do we avoid inheritance hell? Well, in these two views, we can see that there is this commonality between the two views. We have the avatar view. And we can see that we're using a relationship that is inheritance, but it might not be the best way to describe that relationship of the avatar view. Does it make sense to call it an is relationship, which is what inheritance is, or a has relationship? When you think about it, it actually makes a lot more sense to look at these views and say that my profile fragment and pinner fragment has an avatar view. So our previous architecture looks something like this, which inherited from the base class. And our new architecture looks like this. We have my profile fragment, and it's instantiating an avatar view, and pinner fragment that also has that same avatar view. The code looks a little bit like this. So we made some great improvements. One is that we have private member variables instead of protected ones. And secondly, we're passing through custom attributes, which means that we don't have to change that avatar view every single time we're trying to update that class. So our key takeaway here is that we should be deliberate with inheritance. We should think composition first. Inheritance should always be intentional. So in order to do this, you can declare your class as final initially. Thankfully, with Kotlin, all of this is given for free. All classes are declared as closed initially. And you can use inheritance when the is relationship makes sense. For example, a vehicle has tires, and a truck is a type of vehicle. And in the Android fragment world, when we create a custom fragment, we are inheriting from the Android fragment, and that is inheritance. All right, problem number 2. So our second problem is a little bit different from the UI problem I just presented. We have a lot of bugs related with that follow button that we saw. So let me explain. We can see that on the pinner profile, we have this follow button. And basically, what I want to do is when I click on that follow button, I update the number of pinners that I'm following on my profile. This seems fairly simple, but then I introduce all of these other fragments that has a follow button, and suddenly things get complicated, and for some reason, we're introducing a lot of bugs. Well, the crux of this problem is actually a library that we're using. This is an event bus library, and there are many variations of this library, auto, tinybus, etc. You can even make your own custom event queue library. But at the very implementation level, it's a global event queue. What does that mean? Well, when a publisher is sending events, it's sending it to that queue, and that queue is a black box. And when the subscriber is getting events, it's getting events from a black box, and it has no idea where those events are coming from. So the code looks something like this, really simple. I'm just creating a new event and getting the event bus and sending it. And on the subscriber side, I'm receiving that event, and I'm setting the following count depending on that event. So why is it breaking? Well, when we add more and more fragments, we introduce multiple variations of those places that are subscribing to the event and also publishing from that event. And so we don't know what the conditions of those events are that are being sent, or the conditions of the publishers and how they're receiving it. We don't know whether or not the life cycle of the view that's receiving it is alive. And that can cause a lot of problems. Sometimes one bug might just fix another part of the code base and break another part of it. So because it's decoupled, event bus libraries have a lot of pitfalls. There are no enforced responsibility of ensuring that something is listening. And as we add more events, it decreases the reliability and maintainability of the code. It's also just a pain to write tests for. It's really hard to mock out static classes and methods, which event bus is just completely static. So I'm not saying that you shouldn't be using event bus, so don't be scared if you have it in your code base. It just means that we should be using event bus when it makes sense, which is when the client does not care whether or not the event should be consumed. So a good example of this is when we're sending logging events, and those events are being consumed by the server. So I don't really care whether or not those events are successfully sent or not, so I can use event bus. Our solution to this problem is actually really simple. It's just using an interface pattern in order to enforce tight coupling. And although I'm using a very simple version of an interface pattern, observer pattern, there are a lot of variations of this. We have the Android live data observable patterns now, and we also have RxJava, which are more complex versions of an observer pattern. So in here, I've created a follow listener, and I have this follow count changed. And in order to do this, I've implemented that listener on my class, and I'm listening for that following count change. And I'm also registering that listener on the publisher side. And after, when the API successfully comes back, I can now update that follow listener and tell them that the follow count changed. So that's now introducing tight coupling in our UI in order to send events. So our key takeaway here is that event bus libraries are often abused due to its simplicity. UI updates is not a great use case where it benefits from loose coupling. So we should be using event bus for places where loose coupling makes sense, such as logging, and use an observable or listener pattern otherwise. All right, problem number 3. So just looking back at this problem again with the follow button, I'm wondering, why is it that we even need to send events in the first place? Well, when we take a look at the code, we actually see that there's a lot of variations of the model that I'm saving across my fragments. So I'm saving it in my profile fragment, and I'm also saving it in the pinner fragment. And I want to do this in order to cache that model, and whenever that model is changed on one fragment, that means that I have to update the other fragment to say, hey, my model has changed, you should update yours too. This is when I want to facepalm. The reason why this is so bad is because I'm introducing data inconsistencies throughout my app and my views. And we should really not be doing that. So here are some code smells in my current code. One is that we're caching models on a per fragment or view basis. Secondly, we're introducing model-dependent logic in the view layer, and we're updating that view depending on whether or not that model exists, and loading it the API. There are other ways of introducing data inconsistency. In our case, we use UI instances tracking model state, but there's a lot of other ways you can do this. You can introduce global static variables where you're updating some static variable somewhere in your code base just because you need it somewhere and you gotta access it somehow. And you can also introduce variables hidden through a singleton pattern or a utils pattern. So what's the solution? It's really simple. All you have to do is have a central area in order to store and retrieve all of your models. This is what we call a repository. And what that repository would do is when you want to get a model, rather than trying to introduce that logic in your views, you just use the central area, and depending on whether or not it should be fetching from network, disk, or memory, it'll figure it out for you, and it'll pass it back. So this is our solution of user models repository. So we introduce this interface pattern, observer pattern again, and we're implementing a user repository. So now we have a central cache check in order to check whether or not the user exists. And if it does exist, we return that. And secondly, when there is a network call, we also update that model and then return the updated model. Lastly, when on the fragment side, when we implement that model, when we implement the API success, we have a simple call in order to get that model, and we don't have any cache checks here. We're just updating the view with the model. So again, these are all fairly simple examples, simple solutions to problems that can get pretty complex over time. So we've already had a few talks that's talking about ArcsJava. And at the company I previously worked for, at Pinterest, we use ArcsJava in order to work with our repository. So ArcsJava allows us to resolve a lot of asynchronous communication problems, and we can create much more complex solutions, such as chaining data calls and returning more than one type of data response, doing manipulations with that data, et cetera. And what ArcsJava is an observable stream where you're sending multiple events through that stream. So our key takeaway here is that we should be building a central way in order to fetch and retrieve models. You should stop storing your instances of your models in your fragments, views, utility classes, et cetera, and ensure data consistency regardless. Store and fetch models in a central area. So our final problem is one that we probably have a lot of issues with. We didn't write any unit tests. And it's not that I didn't want to write unit tests, but for some reason, the code base I wrote was just so difficult to write unit tests in the first place that if I tried to write unit tests, it would have taken me longer to write the code. So why is it that writing a unit test in this code base is so difficult? Well, all we want to do is ensure that we're correctly setting the user profile data, so it shouldn't be that complex. But this is what our fragment currently looks like right now. We have all of this UI logic, animation logic, networking models, caching, logging, Android services, et cetera. And what we really want to do is unit test the business logic. So in order for us to do that, what does that mean? Well, one, we have to mock out our network callback in order to do this. Secondly, we have to mock out the translation of the response to a model. And then lastly, we have to mock out the Android framework UI using RoboElectric, just to write a simple unit test. So how should a unit test look like? Like, what is the easiest, simplest way I can imagine this unit test of checking that my user profile has loaded? Well, it could look something like this. We just want to validate that my profile is updating the avatar view with the image and the bio description and the name, and we're also updating the following text. So in order to do this, our solution is to separate concerns through an interface. So you've probably heard of all of these different paradigms: MVVM, MVP, MVI, MV, whatever else is coming up next. But the key value that I really want to emphasize here is that they separate concerns between areas that don't need to know about each other. So now you can communicate between those classes and not know the internals of those classes, which makes it a lot easier for us to write unit tests for. So in this case, I'm going to use MVP. I know that this is before I wrote the talk, but after Google came out actually acknowledging that MVVM, and they wrote architecture components for it in order to encourage us to use MVVM as an architecture structure. So if you haven't started doing MVP, you should probably check out MVVM. But in this case, this is what we have. And what this means is that we have the fragment that has the view logic, the presenter that has the business logic, and then the models, which we've already abstracted out from before. And what this means is that when we introduce these interfaces, those fragment and presenter and repository layer is a black box. And in this case, it is actually great to have loose coupling rather than tight coupling. So how do we do this? Well, number one, we're going to define a contract for the view. We're going to create my profile view, and it's going to have the update avatar and update following count. And we have this profile fragment that implements that my profile view. And we're also going to define a contract for the repository. So we define this contract as the user data source, and it has two API calls, the load my user and also the following count of that user. And we're going to implement that data source as well. All of this logic is already written. We're just turning it into, we're just implementing an interface layer of abstraction. So what does it look like on the presenter? Well, we got some great things. One is that we're no longer referencing the implementation of the repository. We just have a user data source. And secondly, we don't have to mock out that really complex Android framework view. We have our own implementation of a view. And finally, we're no longer mocking out the network callback. This is great. So what does unit test look like now? Well, it looks pretty much the same as what we wanted it to be. So it's great. And in order to do this, I had to use a mocking library. I used Mockito in order to mock out the interfaces. And the setup for all of this was pretty simple. So as a recap, the separation of concerns makes the code a lot cleaner. It improves understandability of the code base, which was something that I didn't get into. But not only does it allow us to write unit tests, it allows us to understand what the code actually means. And having view updates can be very distracting when you're reading the code. It increases the reusability of the code base, and our views can now be reused. And it also means that we can use this when we're building libraries and modularizing the code base. So our key takeaway here is that unit tests are easy when you separate out the business logic. So choose a paradigm that makes sense for you to separate out concerns, and use an interface to abstract away internals, and use a mocking library in order to mock out the functionality. And this improves testability and also understandability of the code. And that is all. We made it. Hey, that wasn't that hard. So before I recap the slides, I just want to talk about something called the solid principle. And if you're really interested in being a great engineer, this is an abstraction. This is talking about really great object-oriented programming principles from an abstract sense. So we're talking about single responsibility, about whether or not to open or close a class, etc. So our recap is that, one, we abstracted out a common visual component using inheritance, and that actually made our lives harder as we added new features. So we should be deliberate about inheritance and think about using composition first. Secondly, we noticed that sending events using event bus cause a lot of undetected bugs in order to appear in production over time. So event bus has pitfalls because of its decoupled nature. So we should use tight coupling patterns in order to make sure that these bugs don't go unnoticed. Third is that we were using events in order to ensure data consistency, which is a terrible way in order to ensure data consistency. So we should make a central data storage system in order to store and retrieve models instead. And lastly, we found that we dumped everything into our fragments, and it made it really difficult to write unit tests for. And so if you separate concerns using an interface, you'll increase testability and maintenance of your code. So I've learned that being a good engineer does not mean writing a lot of code, but it does mean being intentional, being aware, and always learning. Here are some additional suggested materials to read about, talking about understanding the different programming paradigms and also how to use live data and ArcsJava. So if you notice all of the drawings that I put into my slides, I actually started a tech comic Instagram a while back. And if you're interested in seeing more, you can follow me. And if you want to see my slides, it's posted at the link. And you can email or tweet at me, or I think we might have time for questions now.
Yeah, thank you for your talk. So you said about central repository for your data. Are you familiar with offline first? And have you tried it, like pros and cons?
Yeah, it's interesting because I actually went from a company that was not really thinking about offline first to a company that was thinking way too much about offline first. And it's like there are pros and cons. What we do at Patreon is that we actually end up storing a lot of the models that we get from APIs, and then we have this problem of having stale data, and it's not a very easy problem to fix. So I think it would depend on whether or not your user really needs to see like cache data, like if performance is really that important of an issue for you. Yeah.
Cool. Well, one more round of applause. Thank you so much, Alice, for joining us.